like smashing balls.
Right.
Or one's playoffs. Or
All right, number 10. Okay, if functions f and g are defined so that the derivative of f equals the derivative of g, that's weird, for all real numbers, with f of 1 equals 2 and g of 1 equals 3, then the graph of f and the graph of g, what?
I know, he said that we didn't do that like the day before, that's something actually we did.
Okay. If the derivative of x is equal to the derivative of g, what do you know is true about the functions? The original one is the same. Is it exactly the same? No. What can be different about the two functions and the derivative will still be the same? No. 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 For example, if I said f of x equals 3x, okay? Oh, no, you're being crazy now. What? Give me a thing that g of x could be, and the derivatives would be the same, but the functions would be different.
Oh,
There you go. 3x plus. Yeah, nice. Let's just use c. Yeah, there you go. So if the derivatives are the same, you know that they're different by a constant value c, right?
Yeah.
9. Okay, so that means that for whatever reason that we want to do this, we can say that if you subtracted the two functions from each other, what would you get as an answer? C. Right? Okay. So what do you get if you subtract these two functions? Well, what is c in this case? Because they gave us some initial values. 1. You know that they're differed by 1 or negative 1. You know that g of x is the same function as f of x, but it's just up 1 unit. Right? Does that make sense? So the functions look exactly the same, but g of x is just 1 unit c higher than the other one. So of those choices, then, which is going to be true? Will they intersect exactly once? No. Will they intersect no more than once? No. Do they do not intersect? Yes. So the answer is C.
well, that's a good question.
It's not about happens.
Nah, but
About dying?
what happens if like
What happens when you die?
no,
Let me
it's
tell you.
like if you're going to the bathroom or something, like and then like they come in here, do this, you're gonna stand here for like 5 minutes.
I
to
think
get
you
back.
probably, they like to tell you about when your time is,
That's
so
like-
you're.
Yeah, I
did
don't
that
think Casey's
before.
going to use the
I'd have
bathroom.
like the worry page, you know?
Yeah.
I do that too.
Oh, I think
I just went.
What's that?
See?
Because I knew that was gonna happen.
Exactly.
Oh, my goodness. All right, the average rate of change of f over the interval from -2 to 3 is 1/5. So you gotta look at the graph. Remember we talked about average rate of change yesterday, right? That is y2 minus y1 over x2 minus x1. So what is y2? 2? Can you see that? You look at the graph, you go over to 3 and up to the graph, and y is 2. Yes? Okay, what's y1? What's y1? What do you get when you plug in -2?
Yeah, I
What-
think get 3.
How did we get? We got 2 for y2. So,
No, I mean like.
oh, x1 is -2,
Oh, okay.
and x2 is 3.
Oh, okay.
Okay, so if you go over to 3 on the graph, 3 on the x-axis, and then up to the graph, y is 2. So right, if you go to -2 and then down on the graph, you get -1. So y2 or y1 is -1, and then x2 minus x1 is 3 minus -2. So what do you get from that?
3/5.
3/5. So that one is no good. Right? Okay, number 2, the slope of the tangent line at the point where x equals 2 is 0. What do you think? Huh? True, yeah. Looks like you got more than one tangent there. Right? You
Yeah.
guys visualize that? It's a maximum point right there. Okay. All right, the left sum approximation of -1 to 3, so we're counting squares, with 4 equal subdivisions is 4. So if you look at the piece from -1 to 0, that's below the x-axis, so that's going to be negative. I feel like this is false, but they're saying true. Oh, left sum approximation. So if you go over to, this is going to be a little tricky without actually seeing the graph.
The graph shows.
No, I know, just so I can, you know. Okay, so if you go from -1 and they want left and 1. Okay, so if I go here, how big is this right there?
1, -1,
Negative, it's not a whole square.
-0.5.
Yeah, half square, so that's going to be -1/2. And then this is the weird one, if I go and make a left-hand subdivision for this one, how big is this rectangle from 0 to 1? It's 0, because on the left is at 0, so the rectangle wouldn't like go up at all, so that one would be 0. And then if I go, so that's 1, 2, 3, so if I go here to here, what would that be? 2. And if I go up from 2 to there, what would that rectangle be? 3.
1.5.
1.5? Okay, so, no.
If you go up the line,
If you go up from 2 and go over, it'd be 3. Yeah, I drew my graph badly. The high point is right here. Anyway, so this rectangle would be 3. So 5 take away a half. They went with true. Because there's about like -half a square that's below here. This is a whole square right here.
So if you go from the left side, don't you have to like put the whole square?
Yeah.
Oh, I see what you're saying. So
I think that's what they're doing.
Gotcha. Okay, yeah, you're right. So that whole, so if you make the whole rectangle, thank you. And that would be -1. Okay, so now we're good. So that was -1. This rectangle is 0. This one's 2. This one's 3. So that adds up to 4. So number 3 is true. So the answer is
C.
C. Right. And then now we're just gonna mourn the dead. That's too much. Okay. All right, we'll try again tomorrow.